Okay, good morning. Welcome to
FamilyMath number 600.
FamilyMath number 600. So today we're going to continue our exploration of James Tanton's question about the 5 dice. What was the question?
So what is the amount of distinct integer values I expect to see if I roll 5 dice?
Okay, so you roll 5 dice, or I think the way he stated it, you roll 1 die 5 times, but either way. How many different integer values do you expect to see? And do you remember what we were seeing yesterday when we did some simulations?
It was like 3.8,
5,
3.5. We were seeing those different numbers each time we did like.
Yeah, but what were we seeing? We
It was around like from 3.5 to 3.6.
Okay, yeah. So I think 3.5 to 3.6. Yeah, that's about what we were seeing.
Yeah.
Okay. So today we're going to calculate it exactly.
All right.
Okay.
And actually, interestingly, yesterday I learned from my friend Chris Long that even a different way to calculate this exactly. But we're going to do it. We're going to do it by looking at the ways that you can get the number 5. And so, for example, 5 could be 1 plus 1 plus 1 plus 1 plus 1.
Okay.
1, 2, 3, 4, 5. That would mean 5 different numbers. Okay.
Yeah.
These are called partitions
All right.
of 5. So can you tell me some other ways that we could see the 5 dice
Well, yeah.
representing different numbers?
Can you use 5? Can you use? Is that the integers have to be positive?
That's right, because these are representing the numbers.
Alright.
So this would be 5 different numbers.
So then you can do like 2 and 3.
Right, you could do 2 plus 3.
I can do
That
two.
would mean 2 dice were the same, and then a different 3 dice were the same. So how many different numbers are we seeing there?
So
Two.
2.
2, yeah.
So we can do 2 plus 1 plus 1 plus 1.
Okay. What I'm going to do is I'm going to write them in increasing order.
Okay.
Just to makes it easier to be systematic about it. 1 plus 1 plus 1 plus 2. Okay, that's good.
So 1 plus 1 plus 3.
1 plus 1 plus 3, yeah.
You could do just 5.
You could do just 5.
You can do 2 plus 2 plus 1.
Okay, I'm going to keep them in increasing order, so I'm going to write that as 1 plus 2 plus 2.
Okay, and then you can do 1 plus 4.
1 plus 4.
Do
I don't think there's any more than that. Let's see. Yeah, I think that's all of them.
Okay, why? Why do you
Well-
think that's all?
We used all the ones with just 1 plus 1 plus 1 plus 1. We used all of them with a 2 in it. We used
the
2
ones
plus
with
3, 2
Well,
plus
just-
3, 1 plus 1 plus 1 plus 2, and 2 twos.
and the ones that have 3 and 4 that we didn't count as separate cases. They're just repeats of
Okay.
what we have.
What do you mean?
Like 3, if we wanted to look at the numbers that have 3 in them, it'd be 3 plus 2 or 3 plus 1 plus 1.
Oh,
we already
okay.
counted those.
All right.
And then 4 is just 4 plus 1.
Yeah, it's a challenging problem to figure out the partitions, but you have indeed successfully figured them out. So that's good. So we're going to count these. I'm probably going to write them in a slightly different order
Okay.
when we start the next video, so that they're not. I'm going to do them in sort of keeping them in increasing order.
Okay.
Okay.
And then we're going to try to count the number of ways that we can see each one of these cases. Okay?
Okay.
Alright.